So we're down there target shooting. We found a little problem, so he's going to try to adjust it here. And do cross drilling with a big drill bit to eliminate some of the weight. That will eliminate the...
I'm thinking, yeah, let's get a...
How you doing, brother?
Oh, I'm good. Just trying to fight the pain.
The fact that he didn't hit his femoral artery. Yeah.
Is that good?
Yeah.
No, that's
Are you ready? Okay, let's take a look at the... That's where it went in. And back there's where it come out. That's where the doctor took it out. Now let's look at what went in you, man. Explain this. Look at this frickin' thing. That's the disco air valve.
When a typical cylinder is filled to its design pressure of 2400 psi, it will contain almost 300 cubic feet of atmospheric pressure gas, or about 160 times the internal volume of the cylinder. This compression of gas represents a tremendous amount of stored energy. If the outlet valve is broken off, the sudden release of compressed gas can turn the cylinder into a missile with energy to shoot through a cinder block wall.
I was ready to see this as not possible. I was totally expecting it not to actually work because it's one of those apocryphal tales and everyone we talked to had heard the story but no one knew anybody that it happened to.
At 40 miles per hour, the air tank turned the cinder block to cinders. It even put a fair dent in the wall 6 feet behind it.
It totally. I mean, it didn't go all the way through, but it went through this one and it was going. It's working its way through that one.
Okay, we have some safety factors to work on, don't we? So first off, you know, these whip valves, as we saw, they can be very dangerous. So what can we do to help prevent that from whacking our eyes, face, or other parts of our body? Well, we're going to use a CHC, a cable hose choker. Yeah, here's one right here. I got this one from Granger. This is a model 3MC05B for what that's worth. It's about 16 inches long, I think, and I believe it's a 1/4 inch. And is supposed to be able to choke the cable. Well, let's see how that works. Well, okay, coming off of the Yong Hen, I went ahead and disconnected what I call the cigarette filter and slid the cable over it so it won't come off of it. And the other end we're going to have that goes to our coalescing filter, so we're going to go ahead and slide the other end of it on and take our quick connect, and there we go. So that's going to keep them from slipping off if they ever should. They now have a good connection and whacking somebody. And I know what you're thinking. Doesn't it look like it's going to slide off? Yeah, it does, doesn't it? So we're going to use the choking function, and that is this opening for the cable loop here does slide. So they've conveniently made it so that you can go on the other end and get it nice and tight so that you can see now it's got a good loop, and it's going to hold it there to where it's not going to come off. If you wanted, I guess you could go ahead and, you know, just put a cable tie or something here on the other side of it so that it can't slide back, and you know, just any little thing just to have it there. But I believe that there is going to hold it in the moment of need. Same on the other side then. So we'll go ahead and put one over coming out of the sieve, that is the desiccant filter, and see what we can do there. So okay, we're going to have to slide it down over this assembly because that's not really going to, well, I guess it could choke there, but I could unscrew it, or in this case, remember that I have my bleed valve up here, so I'm just going to take the knob off the bleed valve, slide this down. It says there, famous last words, screw it back on. And yet, why don't I go ahead and activate a little bit anyway on the choker? So take and squeeze it tight, like that, okay. And on the other hand, coming from the cable that's going to our tank, remember that's about a 95 cubic foot, and we're going to slide that over, go into our quick disconnect, get it so it's fairly close, and once again we're going to get it nice and tight. Like that. Okay. So yeah, I think that's going to make a good connection there so that it's not going to be going all around. So, and then also, you know, when I'm on the paintball field, I should say when I'm near the paintball field, you know, on the picnic tables where sometimes you get these, well, the youth that are up there that are off the street, and, you know, they should be having their barrel sock on their paintball gun, but once in a while you hear one that goes pew. So I always like to wear safety glasses when I'm not on the field, but I'm in the area, so just in case. And yeah, wear them also when you're working around with your compressor. I think is a good way to have a little extra insurance just in case, because you do want both of your eyes, right? So once again, this is called a cable hose choker. And I actually took a look to see about, well, is this the right size? Is a 1/4 inch going to be big enough, or 1/8 of an inch? And so there is a website called www.hosesafety.com. That is HOSE-SAFETY.com. And then it's got a /hose-chokers, CHOKERS. And you could probably do a Google search for it. Just search for cable hose choker calculator, and when you get there, you can plug in some numbers. So with an 1/8 of an inch cable, which is what I have, although on Granger's it says it's a 1/4 inch cable, go figure. But for an 1/8 of an inch cable with a hose inside diameter of a 1/4 inch, yeah, I know that we've only got an 1/8 of an inch on our gear, you can go up to 10,000 psi. Yeah, so certainly if an 1/8 of an inch, you can go probably 15, 20,000 psi, not that you're going to be going that high. And are you curious to see how much pressure can come off this cable if it did come loose? It does have that on the calculator. You can plug it in, so I put for 0.125 inches, that's an 1/8 of an inch, times 4,500 psi. That would be the equivalent of 55 pounds of force. That's with the fluid. And if it happens to be air, it's double. So 110 pounds, 110 miles an hour or whatever, that's whipping pretty fast, isn't it? So yeah, I would say keep it out of your distance. Like in this case, I still think that, well, if it did come loose, what would that do? Let's go ahead and disconnect it. Yeah, it could still come over here, couldn't it? So that isn't going to work. So we're going to have to place it in a way so maybe it's going to be down low to be able to have it so that it won't actually come up. So even though you've got a cable choker, be sure that you have it so that if it does fail, it's not going to come back and still catch you. Okay, well, I hope that helps and you got some good information. Once again, I got mine from Granger's. It was $14.92. Sounds like Christopher Columbus coming to the United States, but that's where you can get some if you want to. So for $15 a cable, probably pretty good insurance. Hope that helps.
This video is capturing my grandfather about 4 feet away from an air compressor that exploded. Basically, the tank looks old, throw it away. These tanks rust from the inside out. Moisture begins to develop inside of the tank. 100 psi can cause a tank to explode, and due to us catching this on video, I felt it as my duty to get this out there in the hope that people share it, and it's about to come up in a couple seconds here. It's coming up right now. There's no audio. It gets up frantically. I was in the house. Thank God I got here 10 minutes before this happened. I come rushing outside. I applied tourniquets to his legs and arm, or we wouldn't have made it.
The other thing is, never ever have these beads come in contact with the aluminum surface. The reason is, these beads leach acid once they get moist. At that point, you now have acid touching the metal pressure vessel. And that won't take long, or I won't say how long it'll take, but that can eventually weaken the threads in the pressure vessel. Not a good thing, okay, when something's filled to 5,000 or 4,500 or 4,000, whatever pressure's in it at the time. It's a below section here, and it's where we let the moisture out that collects, where it condenses. That's the condensate. That's going to be a good sizable part of your water collection. The only thing left is the water vapor. That's what the filter element is made to capture. Filter media can only take 20% of its weight in water volume. In other words, it can only capture 20% of whatever this weighs in water. That's not a whole lot. The filter needs to be able to drain out the moisture. If you're leaving it inside, after the very first time, two things have happened. One, you've let the moisture get into the beads, and now they're really saturated and they're leaching the acid. And two, you've totally destroyed your filter media the very first time. You have to remove the condensate or you're going to destroy your filter.
Okay, I hope you enjoyed the show. I will see you on the flip side. Peace out. Bye for now.